Okay, we have everybody's. That's great news. Happy Tuesday. So here's what I have on the agenda. A summary for the trig functions of angles in standard position. And then if you have any homework questions from the first two sections, I didn't post homework for this section of notes because we had, the homework quiz, the Edmodo quiz, Mother's Day. It just felt like there was plenty going on. So, give me a thumbs up if you have APs this week or next week so I can kind of get a tally. Anybody have an AP this week or next week? Okay. All right, cool, thanks. I'm trying to make sure that we pace this out reasonably for your other obligations. Homework questions, maybe we have some, maybe we don't, and then we'll be graphing sine and cosine functions. So we'll get started with that. So here are the notes that we're writing the summary for from 9.3. So 55 says to sketch an angle in standard position inside a circle with center at the origin to illustrate the sine, cosine, and tangent. 56 says, how does the unit circle simplify the 6 trig functions? And we have those definitions down here on the bottom left in the margin. 57 says, what is a reference angle and why should I care? And 58 says, illustrate the plus minus sign of these 6 trig functions with respect to the 4 quadrants of the coordinate plane. So those are the questions we're going to be answering. All right, so. Okay, so 55. All right, so here's my see if I can get the center right around like that, I think. Okay, so there's my unit circle. So that means this radius right here is 1 unit. So here's the initial side. And sketch an angle in standard position inside the circle center at the origin to illustrate the sine, cosine, and tangent. So here's my angle here. So this is theta. So this is the x coordinate and the y coordinate that where the terminal side intercepts the circle. So the sine of theta is going to be the y coordinate over 1 because the radius is 1. That's the benefit of the unit circle. The cosine of theta is x over 1, or just x, and the tangent of theta will be the y coordinate over the x coordinate. So this one is still a ratio of the x to the 2 coordinates. Does that make sense? Are we okay? All right, okay, looks good. All right, so 56 says, how does the unit circle simplify the 6 trig functions? So when the radius equals 1, then the sine of theta, like we just said, is y over the radius, or y over 1, which is just y. The cosine of theta is x over the radius, or x over 1, which is just x. The tangent of theta is still y over x. But the secant, or the cosecant, I'm going to switch that. The cosecant of theta is the r over y, or 1 over y. And so remember that these two are reciprocals of each other. The secant of theta is the radius over the x, which is 1 over x. And so those two are reciprocals of each other. And then the cotangent of theta is x over y. And it's not so difficult that the tangent and the cotangent, they sound like they go together. Okay, are we good there? Are we ready for 57? All right. Okay, so for 57, it says, what is a reference angle and why should I care? So a reference angle is the acute angle. Do we remember what acute means?
Yes.
From the terminal side to the x-axis. Knowing the reference angle helps us how do I want to say this? So knowing the reference angle means that we only have to memorize the first quadrant and then adjust positive or negative for the angle that whose terminal side I don't think that's the right word. Whose terminal side is in another quadrant. I don't feel like I'm explaining that well. Can you give me a thumbs up if I am not explaining that well?
I don't understand what you mean by like.
Hang on a second, I gotta turn up my volume. Okay, say that again.
I don't get the part that says about the adjusting the plus or minus for the angle.
Okay, so yeah. So if this is my initial side, and let's say the terminal side is over here, and this angle is 225 degrees. So that means this is the same as a 45-degree angle. Does that make sense? Does that make sense or no?
Yeah.
So
are you just saying that because the part on top is 180?
yeah, so exactly. So what a reference angle, you want to think of it as a multiple of an angle that we know in the first quadrant, right? So if this one is 45 degrees here, then the x coordinate and the y coordinate, so this is 1 over square root 2 comma 1 over square root 2, that means this is a multiple of that. So the coordinates here are 1 over the square root of 2, 1 over the square root of 2. But we're in the third quadrant, right? Where the x is negative and the y is negative. So as long as I know what a 45-degree angle the coordinates are in the first quadrant, I know this angle, I know the coordinates of this angle, I know this one, and I know this one over here. The only thing I have to do, as long as I remember this, is to change the x will be negative here, and the y will be positive. We have two negatives here because it's a third quadrant. This is the negative x-axis and the negative y-axis. And then here we'll have what? Positive x, because this is the positive x-axis, and negative y. So does that's what I'm trying to tell you. Does that make
that makes more sense?
Okay, yeah, that's what we're going for with the reference angles. Okay, is everybody satisfied with that explanation? Do we feel more confident about that? Okay. Okay, so 58. So 58 says, illustrate the plus minus signs of the 6 trig functions with respect to the 4 quadrants of the coordinate plane. So here we go. So this is quadrant 1 and 2 and 3 and 4. And here the x is positive, the y is positive. So that means sine is positive, cosine is positive. Let's see here. Let's do the cosecant is positive, the secant is positive, and then the tangent, remember, is a ratio. But two positive numbers over a positive number over a positive number is a positive number. Does that make sense? Are we okay with that one? All right. So the second quadrant, here the x is negative, but the y is positive. So anything that has to do with the x-axis will be negative. So the sine will be positive, the cosine will be negative, the cosecant will be positive, the secant will be negative, and then the tangent will be negative, and the cotangent will also be negative. Okay, so in the third quadrant, we have negative x and negative y. So anything that has the ratio of the two will be positive, but everything else will be negative. So the sine is negative, the cosine is negative, the cosecant is negative, the secant is negative. But as I said, the tangent will be positive and the cotangent will be positive. All right, so in the fourth quadrant where the y is negative, but the x is positive, the sine, the cosecant will be negative, but so will the tangent and the cotangent. So the sine is the y coordinate, so that's negative. The cosine is the x coordinate, but that's positive over here. The cosecant will be negative. The secant will be positive. The tangent will be the negative y over the positive x, so that's negative. And the cotangent will be the positive x over the negative y, so that will be negative as well. Is that part okay? Questions about that? Do you need more time to copy that down? Okay. All right, so do you have homework questions from any of this? Okay, that sounds like no. Great. Okay, so we will start with our notes for today. I wanted to, so normally what would be happening? So if we were on campus, I would be giving you a blank unit circle. I would give you this page, and then you would cut out these triangles right off the corners of the page, and then we would label the lengths of the sides, and the x and y coordinates would make a little bit more sense. So here's what we've got. So this is the 30, 60, 90 triangle, and the short side is 1/2. The long side is √3/2. The radius or the hypotenuse is 1, right? So if I put this here, then you can see that this side is √3/2, which is this coordinate. This side is 1/2, which is parallel to the y coordinate, to the y-axis. So that's why this is 1/2. And the same thing here. I've got a 45, 45, 90 triangle. And so this leg is 1/√2, this leg is 1/√2, and when I put it here, you can see that it fits into this shape. And so that's why the x coordinate is 1/√2, and this is parallel to the y coordinate of 1/√2. So that's where these coordinates around the circle are coming from, is our special triangles. So here are our notes today. I posted these to Edmodo, I think it was 7:45 or so. So this is from 9.4. We'll be graphing sine and cosine functions. So question 59 is to diagram the unit circle. Question 60 is to diagram the fully loaded trig function. And question 61 is how do I graph the sine and cosine function? So the first thing I wanted to show you, this happens to be my example 0. So I've asked you to diagram the unit circle in part A with radians and degrees, and in part B with the coordinates where the terminal side intercepts the circle. So here, so this is 0 degrees and 0 radians. This is 30 degrees, which is pi over 6 radians. This is 45 degrees, which is pi over 4. I kind of remember that one because the 4 here and the 4 here. That's my mnemonic device. This is 60 degrees, or pi over 3. And notice, if it's 30 degrees, then it's a pi over 6. If it's 60 degrees, then it's pi over 3. So I kind of think about, if it has the 6, then it's going to be the 3. If it has the 3, then it's going to be the 6. This is 90 degrees, which is pi over 2. This is 120 degrees, which is 2 pi over 3. This is 135 degrees, which is a pi over 4, so 3 pi over 4. This is 150 degrees, which is 5 pi over 6, and 180 degrees, which is pi. So this is 210 degrees, which is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3, and 270 is 3 pi over 2. So 300 degrees is the same as 5 pi over 3. 315 degrees is 7 pi over 4. And 330 degrees is 11 pi over 6. And that brings us all the way around to 360 degrees, which is 2 pi. So do you want to know how I think about these?
Yeah.
So because when I look at this circle, I feel like it's super overwhelming. So the way that I think about it is, this is 1 pi over 6. This is 2 pi over 6, which reduces to pi over 3. This is 3 pi over 6, which is the same as pi over 2. 4 pi over 6, which simplifies. 5 pi over 6, which doesn't. 6 pi over 6. This is 7 pi over 6. This is 8 pi over 6, which simplifies to 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6, 5 pi over 3. 11 pi over 6, and then 12 pi over 6, which is 2 pi. Somehow that feels more manageable to me. Like I can just count off the angles and get the right thing. And then the same thing works with the 45 degree angles. This is 1 pi over 4, 2 pi over 4, or pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. So somehow just that idea makes it less intimidating for me. Hopefully that's helpful for you. Did that make sense? Anybody want an instant replay of that? Okay. So in part B, I asked you to give me the coordinates. So this is, notice I have all of the X coordinates in turquoise and all of the Y coordinates in purple. So this is 1, 0, because this point right here is the full extension of the unit circle on the x-axis. And because it's an x-intercept, that means the y has to be 0. As you saw with my pink and yellow triangle, this is the square root of 3 over 2, comma 1 over 2. With my pink triangle, this was 1 over root 2, comma 1 over root 2. And then here we have 1 over 2 and root 3 over 2. So again, the 45, it's basically plagiarism. So the x-coordinate is the y-coordinate. But on the 30 degree angle, we have the larger side first. On the 60, when it's a 60 degree angle, then the larger side is second. Does that make sense? So this value is this value and that value is that value. They kind of flip-flop. And then the same thing is true for 90 degrees, right? We have 0 for the x coordinate and 1 for the y coordinate. How are we doing with that? Does that make sense? Instant replay. So we're all good with this? Give me a thumbs up if we're all good with this. All right, okay, great. All right, so in our first example here, we're graphing the parent functions, just keeping it straightforward for you as possible. Okay, so first we've got f of theta equals the sine of theta. So remember, the sine will be our purple y coordinates. Okay. All right, so the first step is b theta minus h equals 0. So in this case, we've got theta equals 0. In our second step, we plug in what we found in the first step. And f of 0 equals the sine of 0. Remember, the sine of 0 is the y coordinate, so that's 0. So that's where this 0 comes from. And then we want to find 4 additional points for our quadrantal angles. Okay, so we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. So f of theta, we found 0, 0 initially in our first 2 steps. Now, when I plug in pi over 2, notice that the sine of pi over 2 is positive 1. So that's where this 1 comes from here. Then when I plug in pi, the sine of pi is 0 because it's an x-intercept. 3 pi over 2. So when I take the sine of 3 pi over 2, that's down here. So that's negative 1. And when I take the sine of 2 pi, that again is an x-intercept on the axis. So that y-coordinate will be 0. Is that okay? All right, that makes sense. We're okay with that? Great. Okay, good. Okay, so what happens here is that the sine and cosine are waves. So I just plot the points, 0, 0 at the origin. Pi over, I'm counting by pi over 2's on my x-axis and by halves on my y-axis. So I've got 0, 0. I've got pi over 2, 1 is this point here. Pi 0 is in my table. 3 pi over 2, negative 1 is here. And 2 pi is 0. So I sketched this part, and then I followed the pattern going this direction. So that is my graph. Is that okay? All right, so the domain goes from negative infinity to infinity because you can keep winding or unwinding the circle. And the range goes from negative 1 to positive 1, brackets on both sides there. So let me know if you have a question. Okay, you guys are doing great. All right, so for part B, we're looking at the cosine function. And remember, the cosine is the x-coordinate. So the turquoise coordinates is what we'll be looking at in our unit circle up here, the turquoise ones. So f of theta is the cosine of theta. Our first step is to set b theta minus h equal to 0, which is just theta by itself because it's the parent function. So when I plug in the 0, I get the cosine of 0 is 1 because the x-coordinate when the angle is 0 is 1. Okay, So coming up with the 4 additional points, these are the usual thetas that we're going to use. Remember, they're the quadrantal angles. So pi over 2, pi, 3 pi over 2, and 2 pi. So the cosine of 0 is 1, as we said. The cosine of pi over 2 happens to be 0 because this is an x-intercept, a y-intercept. So of course the x-coordinate is 0. The cosine of pi is over here, that's -1. 3 pi over 2, the cosine of that again is 0 because that's the y-intercept. And 2 pi, the cosine is, again is 1 because that's our full revolution from 0 to 2 pi. So using the points in the table, I make my graph. Again, I'm counting by pi over 2. And 1/2, 1, and -1/2, -1. So 0 is up here at 1. Pi over 2 is on the x-axis. Pi is -1. 3 pi over 2, again, is an x-intercept. And then 2 pi is up here at 1. So I traced this out, and then I just continued the pattern this way. And again, the domain goes from -infinity to +infinity. And the range is from -1 to +1. Is that okay? All right. So here in the left margin, I have a reminder for the fully loaded function. So f of theta equals a times the trig function, whether it's sine, cosine, tangent, secant, cosecant, cotangent, of b times theta minus h, and then plus k. And so just reminding you that a is a vertical stretch when the absolute value of a is greater than 1. It's a shrink when the absolute value of a is between 0 and 1, and it's a reflection over y equals k when a is negative. B is a horizontal stretch when the absolute value of b is between 0 and 1. It's a shrink if the absolute value of b is greater than 1, and it's a reflection over x equals h when b is negative. So h is a horizontal shift left when h is negative, or right when h is positive, and then k is a vertical shift up when k is greater than 0, or down when k is less than 0. So I feel like we're pretty confident with that. On the back, so I've given us a fully loaded function to try. So stop me when you have questions, because it would be normal that you would have questions. It won't hurt my feelings. Okay, so example 2 says, given the function, describe the transformations, graph the function, and then state the domain and the range. So in part A, I have f of theta equals -4 times the sine of theta plus pi, and then -2. So this is A, this is H, and this is K. So A is -4, that's a vertical stretch by 4, and a reflection over y equals -2. H equals -pi, that should be -pi, sorry. That's a horizontal shift left pi. And K equals -2, that's a vertical shift down 2. So does that part make sense? I feel like that's probably pretty familiar. Okay. All right, so the first step is to set b theta minus h equal to 0. And I've got theta plus pi equals 0, so pi equals -theta. When I plug that in my second step, so f of -theta is -4 times the sine of -theta plus theta minus 2. So this simplifies to 0. And the sine of 0, remember the y-coordinate of that 0 angle is going to be 0 here because it's right on the x-axis. So when I multiply these together, it simplifies to just the k value, which is -2. Is that part okay? Okay. All right. So then when I'm making the the table for the 4 additional points, I've got my usual thetas. I've got the thetas I'm going to graph, and then the y-coordinate. So remember, anytime there's a b term or an h term, you'll have 3 rows in your table. Okay, so these are our usual thetas. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And when I set theta plus pi equal to 0 for the first time, I got negative pi. And so our first 2 steps is these 2 values, right? So when I set theta plus pi equal to pi over 2, I get negative pi over 2. Does that part make sense, or do you want me to show it to you?
Can you show it to us?
Yeah, absolutely. Okay, so let's move this over. All right, so okay, so we've got 0 and negative pi and negative 2, and then pi over 2. Okay, so how do we find this value is what we're looking for. So we would have theta plus pi equals pi over 2. Am I on the screen? No, I'm not. Okay. So I subtract pi from both sides, and I get theta equals pi over 2 minus 2 pi over 2. Oops. So that simplifies to negative pi over 2. Does that make sense? So this value right here, this is how I got this value here. Okay, great. And then when I'm considering it, I'll say f of pi over 2, which is, this is how I'm getting the y-coordinate now because the f. So we've got negative 4 times the sine of pi over 2, and then minus 2. So the sine of pi over 2 happens to be positive 1. Does it make sense that it's positive 1?
Does pi over 2 equal the negative 1?
That's a great question. So pi over 2 is the angle, right? The quadrantal angle right up here, right? This one. So it's this angle right here. So that's pi over 2. And then the coordinates are 0 and 1. And because I'm saying the sine, I want the y coordinate.
Okay, then yes.
Okay, great. Yeah, these are, I feel like there's a section missing in the notes. Like there should be a whole section about the unit circle before we start graphing, but for some reason, we don't quite have that yet. Okay, so this is negative 6, right? Because negative 4 minus 2 would be negative 6, which is how I got that value. Is that part okay? All right, great. Okay, so do we want more explanation of the rest of the table, or does it make sense how we find those values?
It makes sense.
Okay, great, thank you. All right, so then from there, now that I have the table, I've counted by pi over 2 still on my graph. That still works. But notice I start over here at negative pi, which is the y-coordinate is negative 2. I'm counting by 2's on my y-axis, by the way. Negative pi over 2 is negative 6. 0 is negative 2. Pi over 2 is positive 2. And pi is negative 2. So my graph kind of starts here, and then I just finished it out. Does that seem okay? So we're okay with the graph, or you have questions? Okay. So the domain goes from negative infinity to positive infinity. That will be the case. But notice the range is shifted because of that -4, that vertical stretch, and then also the k, which is the shift down. So we've got from -6 to +2. All right, are we okay there? Does that seem reasonable? Okay. All right, so here is part B. This is the, I've got a cosine function here. So f of theta equals the cosine of 4 theta minus pi over 2 plus 1. So notice B is 4. So when I factor that out, I get theta minus pi over 8 plus 1. So the cosine, so B is 4 here. That's a horizontal shrink by 1/4. H is pi over 8, which is a horizontal shift right, pi over 8. K is 1, which is vertical shift up 1. Does that seem familiar? Like, the transformations, are those okay, Kings? Okay, great. Okay, good. All right, so the first thing that we want to do is set b theta minus h equal to 0, which is 4 theta minus pi over 2 equals 0. This just really confirms what we've noticed in the horizontal shift here, right? So I move the pi over 2 over, I divide by 4, and I get pi over 8. So that's what we had. That confirms it. We're in good shape. The next thing I want to do is plug this value in. So when I plug it in for theta, and I multiply these, I again get pi over 2. Pi over 2 minus pi over 2 is 0. Remember, the cosine is the x-coordinate. So the cosine of 0 is 1. Are we comfortable with that? So we're not comfortable with that? You want me to explain how that works? Okay, so remember, the cosine is asking about the x-coordinate. So the x-coordinate of 0 is the angle 0 degrees is 1, because it's the whole extension of the radius. So then we have this plus 1, and that gives us 2. So in this example, when I'm finding the 4 additional points, I've color-coded some of the background data here. So when b theta minus h equals 0, we get the angle pi over 8 and the y-coordinate 2. And so when I set b theta minus h equal to pi over 2, so in that case, we got 4 theta minus pi over 2 equal to pi over 2. I add the pi over 2 to the other side. That gives me pi, because pi over 2 plus pi over 2 is pi. Then when I divide by 4, I get pi over 4. So this work here is how I came up with that value. Then when I plugged in pi over 2 into my function, cosine of pi over 2 plus 1, now the x-coordinate of that first quadrant angle is going to be 0, right? Because that's lying on the y-axis, so of course the x-coordinate is 0. So 0 plus 1 is 1. So give me a thumbs up if we're okay about that, and then we'll talk about the green one and the blue one. Okay. All right. Vince, does this make sense? Okay. Jack, you're good? All right. Okay, so in order to find this theta to graph, I set 4 theta minus pi over 2 equal to pi. I added pi over 2 to both sides. So 2 pi over 2 plus pi over 2 is 3 pi over 2. When I divide by this coefficient 4, I get 3 pi over 8. So that's where that comes from. When I plug in the pi, the angle that we were originally talking about, so the cosine of pi plus 1, but remember, pi the cosine or the x-coordinate of pi over here is -1. So this -1 plus the vertical shift up cancel out and we're left with 0. Okay, so 3 pi over 2, when I repeat those processes, I get pi over 2, and the y-coordinate is 1. And when I plug in 2 pi, I get 5 pi over 8, and also 2 for the y-coordinate. So notice there's definitely a pattern to the y values. So please look for that, please expect that. So that it's a nice way you can quickly check your answers and realize, so on the sines, these will be the same, and then there'll be a symmetry here on the cosines functions when you're making your tables. So here's my graph. I decided to count by pi over 4 or 2 pi over 8. So we initially had 0, pi over 8, 2. Then we have pi over 4, which is 2 pi over 8, 1. So I have a point. That's my first point. Here's my second point. 3 pi over 8 is here on the x-axis because the y-coordinate is 0 from our table. There you go. Then we have pi. I'm sorry, that's the 3 pi over 8 is shifted. The pi over 2 is back at 1. And then the 5 pi over 8 here is up at 2. So really this was the portion of the graph that I had, and then I just extended it to cover the whole x-axis that I've shown here. Are we okay with that part? Great. So the domain again goes from -infinity to +infinity. And the range goes from 0 to 2 with brackets on the range. Great. That's it. That's what I got for you. Do you have any other questions? All right, King. So if that's if we're good, then I will let you go on to your second period class. So I'll be the last one to leave in case anybody has any questions or things they want to. Vince, can I touch base with you for a second? But everybody else, you can have a great day.
Thank you.
You're welcome.
Thank you.
You're welcome. You're welcome. Have a great day.
I actually have a quick question.
Sure.
I was gonna plan on a while ago doing my personal finance test. Could I still do that now?
Yeah. Have your mom email me.
Okay, and then would you just send it to her and we would do that?
Well, I kind of want to discuss what, if she's going to proctor a test, then I want to discuss what her responsibilities are for that. And then,
Okay.
yeah.
Okay, perfect.
Then I'll email it to her and you guys can drop it off at my house or mail it back to me or whatever. Yeah.
Thank you.
You're welcome. Take it easy.